Hello, this is Dr. Hanaa Assil, and this is paper 1C of January 2023 in the Pearson Edexcel IGCSE. Let us take a look at the questions and discuss the answers. The first question in this paper says, this question is about the three states of matter: solid, liquid, and gas. The diagram shows how particles of a substance are arranged in two of these states. Complete the diagram to show how particles are arranged in the liquid state. I'm going to remind you that in the solid state that he drew, he has regular rows closely packed. The particles are in regular rows closely packed. In gas, they are randomly arranged very far apart. Now, what about liquid? You should realize that when you're drawing the particles of a liquid, they should not be in regular rows. So this is a random arrangement. They are near to each other in clusters. That means that some of them are touching, some of them are not touching, and you should start filling from down because a liquid will fill a container from down. Okay, identify the state of matter that contains particles with the least energy. Which of these has lower energy? You should remember that as we go from solid to liquid, the liquid has more energy, the gas has a lot of energy. So the one with the least energy is the solid. The table shows two changes of state. Complete the table by giving the name of each change of state. Okay, let's remind ourselves. What are the changes of state? If we're going from solid to liquid, that is melting. So that first question, solid to liquid, is melting. Liquid to gas, boiling, or we could refer to it as evaporation. Now, going the other way around, gas to liquid is condensation. Liquid to solid is freezing. What about solid to gas? You should see that solid to gas is sublimation. Explain how hot water evaporates. Explain why hot water evaporates more quickly than cold water. What happens during evaporation? When the water is heated, it evaporates more quickly. Why is that? Because the particles have more kinetic energy, move faster, overcome the attraction forces between them, and move further apart, so the particles on the surface will escape first from the liquid. Okay, so this is what happens during evaporation. Question 2 says, this question is about elements, mixtures, and compounds. Which of these is the formula of a molecule of an element? What's a molecule and what's an element? A molecule means two or more atoms. So A is not a molecule. The oxygen alone is an atom, it's not a molecule. So A is not my answer. Now, molecule means I need two or more atoms bonded together. Now, element means all of these atoms should be the same. So I cannot choose H2O. H2O is not an element, it's a compound. HCl is a compound. So the only one there that's an element and a molecule is Cl2. Which method can be used to separate an insoluble solid from a liquid? So I have something at the bottom of the beaker in a liquid and I want to get it out. So how do we separate it? You should remember that that is by filtration, in which the insoluble solid will be collected in the filter paper as residue and the liquid will go down and be collected as the filtrate. Give the name of a method used to separate a mixture of liquids with different boiling points. How do we separate a mixture of liquids that have different boiling points? You should know. This method is called fractional distillation, in which you have the liquid being heated and then it goes up through the fractionating column, and then the one with lower boiling point will be collected first in that receiver. The gas is cooled and condensed in a condenser and collected in the receiver. So this is the method that we use to separate a mixture of liquids that have different boiling points. A student adds a crystal of substance X to some water in a beaker and leaves the beaker for 1 day. The diagram shows the beaker immediately after adding the crystal and after 1 day. Which equation gives the correct state symbols for a process that occurs in the beaker? Now, what is happening in the beaker? He has a crystal at the bottom of the beaker. What is going to happen? Of course, this crystal is going to dissolve in the water and form a solution. So we are starting with a solid and it forms a solution. So its state becomes aqueous. Can you see that? So the answer is D. Which other process occurs in the beaker? So we said, okay, good. The crystal will dissolve and then it will do what? Remember, the particles will move from area of high concentration to area of low concentration. This is called diffusion until all the beaker has equal amounts of the crystal. After 1 day, the student does 2 tests on the liquid in the beaker. The table shows the student's results. So he did a flame test and he got lilac flame. Which substance gives lilac flame? I'm going to remind you that these are the substances you're supposed to know. Lithium gives red. Sodium gives yellow. Which one gives lilac? Potassium. Remember that these are tests for the ion. So this is a test for potassium ion, K+, not potassium metal. So what you have, if he says write the formula of the substance present, it is K plus or Li plus or Na plus or Ca2 plus or copper 2 plus and so on. Do we understand this? Okay. Then he added acidified barium chloride and he got a white precipitate. So the first thing you're going to ask yourself, barium chloride is test for what to give me a white precipitate? Remember that barium chloride is test for sulfate. That means when he says identify the substance, that means tell me the name of the substance present. Of course, we found that we have potassium and sulfate, so my substance is potassium sulfate. Okay? This question is about gas. Name the gas that is about 1% of dry air. You should know the composition of air. What is about 1% of dry air? You should know that that is argon. Which is the most abundant gas in dry air? Which one is present in larger amount in air? You should know that it is nitrogen. So we have argon is 1%. You should know that oxygen is 20% or 21%, and nitrogen is 79%. Carbon dioxide is a very small amount. Carbon dioxide is about 0.03, and methane should be not present at all, but actually sometimes it is. A student uses this apparatus to find the percentage by volume of oxygen in a mixture of oxygen and neon. So he put in the test tube a mixture of oxygen and neon. It's not air, oxygen and neon. And he put wet iron wool. You should know that when I have wet iron wool, what will happen to the iron? If it is wet, that means there is water. And the tube has oxygen, so the iron has water and oxygen. What happens is it will take the oxygen in order to rust, to form hydrated iron oxide, which is rust. So this is the student's method. Measure the initial length of the column of gas in the inverted test tube. Leave the test tube in a beaker for a week. Measure the final length of the column of the gas. So he's the iron for a week so that the iron will use up the oxygen that is in the test tube for rusting. So what happens to the level of water inside the test tube? You should realize that the level of water inside the test tube will go up to replace the oxygen that was used up. Okay, some of the iron wool rusts. give the chemical name for rust. You should remember, if we're talking about appearance, the iron before rusting is like any other metal, it's silvery gray. But after it rusts, it looks reddish brown and flaky. Flaky means it will peel off easily. And the name of rust is what? The name of rust, remember that the iron took water and oxygen in order to rust. The final substance is called hydrated iron 3 oxide, Fe2O3, iron 3 oxide, hydrated iron 3 oxide. This is what we call rust. Give a reason why neon does not react with the iron wool. Would the neon react with the iron wool? Of course not. Why? Because if you look at the periodic table, where is neon? Neon is in group 0 or group 8. Which group is that? That is the noble gases, the unreactive gases that do not react because they have a full outer shell of electrons. So neon is unreactive because it has a full outer shell of electrons. The table shows the students' results. So at the beginning, the column of gas was 75 millimeter. Now, after the iron took all the oxygen from the gas, now the column is 30 millimeter. Use the results to calculate the percentage of oxygen in the mixture of oxygen and neon. So let us see. What are we doing here? He said at the beginning it's 75, at the end it's 30, and that means the difference is the amount of oxygen over the total times 100. That's how you get percentage. So the 75 minus 30 over the original 75 times 100, that makes up 60%. That means the mixture originally had 60% of oxygen. A student uses this apparatus to investigate the dyes in a food coloring A. Explain 2 mistakes that the student makes when setting up this apparatus. What is wrong with this apparatus? Well, let's see. Can you see the level of water and the baseline? The level of water is above the baseline. Is that correct? That's wrong, of course. The level of water should be below the baseline. So one mistake here is level of water should be below the baseline. Why? Remember, he's saying explain, and you have 4 marks. You're supposed to explain 2 mistakes. That means you tell me the mistake and you explain why it's a mistake or what is wrong. So, first of all, level of water should be below the baseline, not above it. Why? Because we want to avoid dissolving the spot in water. All this A will dissolve in the water instead of going up the chromatography paper. Now, what's the second one? The second one, he said, baseline is drawn in what? The baseline is drawn in ink. That's wrong. The baseline should be drawn in pencil. Remember, pencil will not dissolve in the water, but ink will dissolve in water, and that will interfere with the results. So all of this will go up. The spot and the baseline, everything will go up on the paper. So please remember, the common mistake here is you just say the mistake and you don't explain. When he says explain the mistakes, that means you tell me what is the mistake and you explain it. And each of these has 2 marks. Then he says the student repeats the experiment but with no mistakes. So now he's going to do it properly. The table shows the RF values for the 2 dyes in food coloring. First of all, what do we mean by RF value? Do you remember the meaning of RF value? The RF value of any of the spots is the distance traveled by the spot over the distance traveled by the solvent. So if he says that the blue color has an RF value of 0.5, that means it traveled half the distance of the solvent. Remember, the solvent will travel to the top. So if this is 0.5, then the blue spot is about in the middle, somewhere in the middle. Yellow is 0.25. That means it's about a quarter of the way up. Do we understand this? And then he says, complete the chromatogram by adding and labeling. So I am drawing it in color, but you're not going to draw it in color, so you need to label that this is the blue one and this is the yellow one. So the blue one is halfway up the paper, the yellow is 0.25, that means a quarter of the way up the paper. Give a reason why the blue dye has a larger RF value than the yellow dye. Remember, we said if something goes up further on the paper, what does that mean? It means that it is more soluble in water. So the blue dye went up higher. That means the blue dye is more soluble in water than the yellow dye. And remember, we said if one of the colors stays on the baseline, does not move up at all, we say it is insoluble in the solvent or in the water. Okay? A student investigates reactivities of 4 metals: aluminium, magnesium, copper, and metal X, which we don't know what it is. The student adds pieces of magnesium to solutions of the sulfates of each metal. So we're adding magnesium to a solution of the other metals. After a few minutes, the student removes the pieces of magnesium ribbon, records the appearance of each piece of magnesium. So he put magnesium on aluminium sulfate. He got a gray coating on magnesium. That tells you that it reacted. And that tells you that magnesium is more reactive than aluminium. Remember, if the metal displaces another metal, that means it's more reactive. So magnesium with aluminium sulfate react. That means magnesium is more reactive than aluminium. Now, magnesium with magnesium sulfate, there is no change. Of course, because you cannot the magnesium cannot displace itself. Magnesium with copper sulfate got a brown coating. That means it reacted. That means magnesium is more reactive than copper. Now, magnesium with X got a gray coating on magnesium, and that means that magnesium is also more reactive than X. Now, name the substance that causes the brown coating on the magnesium. Name the substance that causes the brown coating of magnesium. That is the magnesium with copper sulfate give a brown coating. That is because the magnesium displaced the copper and you got copper on the magnesium. Remember that magnesium is the only metal that is reddish brown, or we refer to it as brown. All metals are gray or silvery in color except copper, which is brown, and gold, which is yellow. State why there is no change with magnesium sulfate. Of course, if he puts magnesium on magnesium sulfate, there will be no change. The metal cannot displace itself, so magnesium does not displace itself. The student repeats the experiment with pieces of metal X instead of magnesium. So now we're putting X on aluminium sulfate, X on magnesium sulfate, X on copper sulfate, and so on. Now, you can see that X with aluminium sulfate, it did not react. That means aluminium is more reactive than X. With magnesium sulfate, no reaction. That means magnesium is more reactive than X. Now, with copper sulfate, it reacted. That means which one is more reactive? That means the X is more reactive than the copper. So use the information to deduce the order of reactivity. What did we say? We said the magnesium more than aluminium, and then when we compare the X and the copper, we said it is the X that is more reactive than copper. So give a possible identity for X. Well, if you look at the reactivity series, magnesium more than aluminium, and then X is in between aluminium and copper. So what is X? X could be zinc or iron or tin. Do we understand that? This ionic equation represents the reaction between magnesium and aluminium nitrate. Explain in terms of electrons. Which species acts as a reducing agent? So this is the equation. Now, we need to know where is oxidation and where is reduction. And you know that whichever substance has been oxidized, it is the reducing agent. And the one that has been reduced is the oxidizing agent. So from magnesium to magnesium 2+. That means magnesium has lost electrons. Loss of electrons is oxidation. Aluminium 3+ to aluminium 3+ gained electrons, that is reduction. So the one that has been oxidized is the reducing agent. The one that has been reduced is the oxidizing agent. So he's saying which species is reducing agent? That's magnesium. Why? Because it is the one that lost electrons. It is the one that gave electrons to the other substance and caused it to be reduced. Okay? This question is about polymers. This is the structure of a monomer. What is the name of this monomer? How do we name any organic compound? First of all, how many carbons? Can you see that I have 2 carbons? 2 carbons means it should be F or prop. 2 carbons is F, so A or B. Now, it has a double bond. That means it is ethene. And it has a chlorine on it. That means it is chloroethene. Okay? Complete the equation to show the repeat unit of the polymer that forms from this monomer. How do we draw the polymer? If I have a double bond, I make it a single bond. Bond on the right, bond on the left to join it to another compound before and after, and I put a bracket with an N and I copy everything exactly as it is. So this is the structure of the polymer. A molecule of the polymer has a relative molecular mass of this number. So this is the MR of the polymer as a whole. Show that the number of monomer molecules needed to make this molecule is about 40,000 monomers. So this was the monomer. This is one of them. And he's asking how many do I have in the polymer? So in order to do that, I get the MR of this monomer. So the MR is this. 62.5. So this is the one repeat unit or one monomer, because the monomer is just the one that had a double bond in the middle. So it doesn't make a difference with the MR. So the MR of the monomer or the MR of the repeat unit is 62.5. Now he says the polymer as a whole is this 2,490,000. And that means I just divide that number by 62.5 and I find the number of monomer molecules that I have. So this is about 40,000. These are 2 methods used to dispose of the polymer, either burying it in landfill sites or burning. Discuss the environmental problems caused by these 2 methods of disposal. So if I bury the polymers, remember we said polymers are plastics. They are usually non-biodegradable. So if you bury them in the landfill sites, they accumulate in landfill sites. So this is a problem of burying. But if I burn it, that's also a problem, because when burnt, they release toxic gases. So these are the 2 main disadvantages or 2 main problems of the use of polymers. A different polymer molecule contains this number of atoms of carbon, this number of atoms of hydrogen, this number of atoms of chlorine. Determine the empirical formula. So in this case, he's already giving me number of atoms. So I just divide by the smallest to determine the simplest ratio between the atoms. So the empirical formula of this polymer is CHCl3. Remember, you don't need to divide first by atomic mass of each one. You can directly get the simplified ratio of the number of atoms. The table shows the displayed formula of some organic compounds. Give a reason why compound X is not a hydrocarbon. Where is X? Can you see X? Is this a hydrocarbon? It's not a hydrocarbon because it's not made up of carbon and hydrogen only. It contains oxygen. And we said hydrocarbons have only carbon and hydrogen. Give the letter of the compound that is a saturated hydrocarbon with the empirical formula CH2. Remember we said, what do we mean by saturated? Saturated means no double bonds. And he wants it with empirical formula CH2. We said this applies only to the saturated hydrocarbon if it is a cyclic compound. The cyclic compound has the number of hydrogens twice the number of carbons. Remember that the normal saturated hydrocarbon, which is alkanes, a normal alkane will have CnH2n plus 2. That means the number of hydrogens is twice the number of carbons plus 2. But if it is cyclic like W, all the carbons joined in a cycle around each other, then the number of hydrogens is twice the number of carbons. So my answer here is W. Give the letter of the compound that produces 9 moles of water when 1 mole undergoes complete combustion. So we're talking about one of these in which if I burn it, it gives 9 moles of H2O. Okay, in order to give 9 moles of H2O, I must be starting with something that has how many hydrogens? Can you see that? If it is 9H2O, that means I should start with something that has 18 hydrogens. So the question is, which of these? If it has 18 hydrogens, then it must have 8 carbons because they are alkanes, and the alkanes have CnH2n plus 2. So which one applies to this? So that is V. The others, if you try doing them, they will not give 9 when you balance the water. Give the structural formula of the compound Y. Where is Y? What do we mean by structural formula? The diagram drawn here for Y is called displayed formula. Now, to write it as structural formula, you collect the number of hydrogens for each carbon. So that first carbon has 2 hydrogens, and then a double bond, and then a carbon that has 1 hydrogen, and then a carbon that has 2 hydrogens, and the final carbon on the right has 3 hydrogens. So this is how you write structural formula. Explain why compounds W and Y are isomers. Where are W and Y? Well, W and Y, each of them has 4 carbons, 8 hydrogens, but they're just drawn in different ways. So that is what we call isomers. So isomers have the same molecular formula, but different displayed formula or different structures. Okay, so these are isomers. Compound Z reacts with bromine. Where is Z? This was Z. Compound Z reacts with bromine in presence of ultraviolet radiation. Remember, Z is an alkane. When alkanes react with bromine or chlorine, they need UV light. That is the condition. And what happens is that you have the alkane. So this alkane that I have now is C4H10. I'm reacting it with bromine. Now, one of the hydrogens is removed and replaced by 1 bromine. So instead of having C4H10, we now have C4H9Br. So we removed one of these hydrogens and put a Br. So my other product is the hydrogen that was removed and the Br that remained from the Br2. So my other product is hydrogen bromide. Now, what is the name of this type of reaction? Remember, reactions of alkanes with halogens in presence of UV light, that is called substitution reaction. Describe how the combustion of sulfur-free petrol in a car engine produces gases that can cause acid rain. Do not refer to carbon dioxide. First of all, because carbon dioxide does not cause acid rain, carbon dioxide causes global warming. So we're not talking about carbon dioxide. Now we're talking about the gases that cause acid rain. Now, which gases cause acid rain? You should know that sulfur dioxide causes acid rain, but he's saying we're using sulfur-free petrol, so we don't have sulfur. What is the other gas that causes acid rain? You should remember the other cause of acid rain is oxides of nitrogen. Now, oxides of nitrogen come out of car exhausts, and these go into the rainwater or dissolve in rainwater to form acid rain. Now, how are oxides of nitrogen produced in the engine? You should remember that the high temperature in the engine causes nitrogen and oxygen gases in the air around the engine to react. This forms oxides of nitrogen, and these gases are released from the car exhaust and dissolve in rainwater to form acid rain. So this is one of the gases that causes acid rain. This question is about ionic compounds. The table gives formula of some positive and negative ions and the formula of some compounds containing these ions. Now complete the table by giving the missing formula. So where do we have a missing formula? The one between Na plus and Cl minus. How do we write? This should form sodium chloride. How do we write sodium chloride? You should remember, we write the symbols and then the valency of one under the other. But since each of them has only one charge, that means their valency is 1 and we don't write anything. Now with magnesium chloride, the valency of magnesium is 2. He gives you that it has a charge of +2, and you should know that it belongs to group 2, and that means I need to put a 2 under the chlorine. Remember, we put the valency of 1 under the other. What about magnesium ions and nitrogen or nitride ions? So magnesium has a valency of 2, so the valency of magnesium goes under nitrogen. Nitrogen has a valency of 3. You should know that even if he does not tell you, he's telling you it has 3 minus. So that is valency 3. And if you look at the periodic table, you should see that it is in group 5, and that means valency 3. So I have to put 3 under the magnesium. Give the name of the compound with the formula MgO. What is MgO? Mg, of course, is magnesium. Now, O is oxygen, but when it is a compound, we don't say oxygen, we say magnesium oxide. So that is MgO. Calculate the relative formula mass of Na3N. How do we calculate MR of anything? The MR is just the total of the mass numbers. So either we're going to look at the periodic table and choose which ones the mass numbers are, the bigger numbers. So sodium has 2 numbers, 11 and 23. The mass number is the 23. Nitrogen has 7 and 14. The mass number is the 14. We use the bigger number, even if he does not tell me. In this question, he tells me that the sodium is 23 and the nitrogen is 14. Now, how many sodiums do we have? We have 3 of them. So that's 23 times 3. Plus, I have 1 nitrogen, which is 14. So the MR of this compound is 83. The diagram shows the arrangement of electrons in atoms of lithium and in an atom of oxygen. Describe the changes in electron configurations of lithium and oxygen when these atoms form lithium oxide. So you can see that originally the electron configuration of lithium is 2,1. Oxygen is 2,6. Now, when they react, what happens? You should realize that each of the lithium will lose 1 of its electrons. The oxygen needs 2 electrons, so that means 2 atoms of lithium will lose 1 electron each, so their configuration changes from 2,1 to 2. And the oxygen atom gains 2 electrons, so the electron configuration changes from 2,6 to 2,8 because he wants electron configuration. Lithium oxide has a giant ionic structure. Explain why lithium oxide has a high melting point. Well, you should remember that giant ionic structures means it has strong electrostatic attraction forces between what? between the positive and negative ions, and this needs a lot of energy to be broken, so ionic compounds usually have high melting points. This question is about substances that contain covalent bonds. The diagram represents a molecule of oxygen. Describe the forces of attraction in a covalent bond. What is holding these two atoms together, or what is meant by a covalent bond? Remember, a covalent bond is a strong attraction forces between the bonding pairs of electrons that are being shared between the atoms and the positive nuclei of the two atoms. So each atom has a positive nucleus. They're sharing electrons between them. There is a strong attraction force between the shared pairs of electrons and the positive nuclei of the atoms. This is what we mean by covalent bond. So please, when he says what is meant by covalent bond, don't say it's a bond between two nonmetals. That's not a definition of covalent bond. We say the covalent bond is the strong attraction forces between the bonding pair of electrons or the shared pair of electrons and the positive nuclei of the atoms. The table shows the boiling points of 3 group 7 elements. Explain the trend. And that means you need to tell me what is the trend and why. What do we mean by trend? It means going from fluorine, chlorine, bromine. What is happening to the boiling point? Is it increasing or decreasing? So you should realize that as we go from fluorine, chlorine, bromine, the boiling point is increasing. Now, why is it increasing? You should realize that these are covalent molecules. So what they have is they have weak attraction forces between molecules. So if he's saying why the boiling point is low for any of them, it's because there is weak attraction forces between the molecules. Okay, then why is bromine higher boiling point than fluorine, for example? This is because as we go down the group, the atom becomes bigger, more electrons, so the forces between the molecules become strong. So first of all, what is the trend? Boiling point increases going down the group. Now explain. This is because the molecules get bigger, more electrons, so there's stronger attraction forces between the molecules that need more energy to be broken. Graphite is a naturally occurring form of carbon. Explain why graphite is soft and conducts electricity. And we need to refer to structure and bonding. Now, what is graphite? This is the structure of graphite. Remember that graphite, if we say describe the structure of graphite, it is giant three-dimensional structure in which each carbon atom is covalently bonded to 3 other carbon atoms in layers of 6-sided rings with weak attraction forces between the layers. So, explain why graphite is soft. We say it is soft because weak attraction forces between the layers allows them to slide past each other or slide over each other. Why does it conduct electricity? Because it has free-moving delocalized electrons. It has free-moving delocalized electrons because each carbon atom is covalently bonded to only 3 other carbon atoms. So each carbon atom should have 4 electrons in its outer shell because carbon is in group 4. So if it's using only 3 of them for bonding with other carbon atoms, then each of the carbons has 1 electron that is free to move and conduct electricity. A student uses this apparatus to record the maximum temperature in the reaction between solutions of hydrochloric acid and sodium hydroxide. This is the student's method. Add 25 centimeter cubed of hydrochloric acid to the beaker. Add 25 centimeter cubed of sodium hydroxide solution to the beaker. Stir the mixture. Record the maximum temperature. Remember, the word maximum temperature means that the temperature will go up. Name a suitable piece of apparatus to add 25 centimeter cubed of solution. Now, if he says he wants to add 25 He didn't say 25.0. He said just 25. That means about 25. So I need a measuring cylinder. If we say at 25.0 centimeter cube, that means exactly 25. Then in that case, I would need a pipette, or you could use a burette. Before the reaction, both solutions have a temperature of 21 degrees Celsius. The heat energy change Q is this number. Calculate the theoretical maximum temperature reached by the mixture, which has a mass of 50 grams. You know that if he gives me Q, Q is mc delta T. M is the mass of the solution, C is 4.2, it's a constant, and delta T is the temperature change. So he's given me the mass and the C and the Q, and he wants the temperature. So first we need to get the temperature change. The temperature change is Q over mc. That is the number he gives me over the mass, which he says is 50 times 4.2. So the delta T is 13.7. This is not the final temperature. This is the rise in temperature, or the change in temperature. And he's saying originally it was what? Originally it was 21. So the final temperature is 21 plus that change. So my final temperature is 34.7 degrees Celsius. Give a reason why the maximum temperature recorded by the student is lower than the theoretical. So we're saying the temperature should rise by 34.7 or to 34.7, but actually what he measured is less. Remember, he's doing this in what? He's doing this in a beaker, and we said when we're measuring temperature, actually we shouldn't do the experiment in a beaker. We should do it in a polystyrene cup. So this is in order to do what? This is in order to avoid loss of heat to the environment. So when he does it in a beaker, some of the heat has been lost to the surroundings or to the environment. In the reaction, 0.05 mole of hydrochloric acid completely react. Calculate the molar enthalpy change, which is delta H, and include a sign. How do we get delta H? You should know that delta H is Q over N. He already gave me Q, and he gave it to me in joules. It was 2,880 joules. So when I put it here, I need it in kilojoules. So I need to divide that by 1,000. So it's 2.88. Divide by the number of moles, that gives me a number. Remember, he says include a sign. How did I know that it should be minus? Because he said that the temperature rises, or there is a maximum temperature. So if the temperature rises, that means the reaction is exothermic, and that means delta H is a negative number. This question is about the reaction between magnesium and dilute nitric acid. A student reacts dilute nitric acid with excess magnesium powder as a first step in the preparation of dry crystals of hydrated magnesium nitrate. So he's trying to prepare magnesium nitrate. He puts magnesium on dilute nitric acid. And remember, he's saying he has dilute nitric acid and excess magnesium. Why is it important that the magnesium is in excess? Well, we need to put a lot of magnesium because we need to make sure that all the acid reacts, so that at the end, my final solution should contain only the magnesium nitrate that I want, not magnesium nitrate and excess nitric acid, for example. So we put excess magnesium to make sure that all the acid reacts. The student adds 0.75 grams of magnesium to 0.025 mole of nitric acid. Calculate the mass of magnesium in grams that remains at the end of the reaction. Remember that we said the magnesium is excess. That means some of it will remain at the end. Now, if I look at this, he said I'm using dilute nitric acid and excess magnesium powder. Now, we're reacting 0.75 grams of magnesium with 0.025 mole of nitric acid. So if I look at the equation, you should realize that First of all, if I have 0.75 grams of magnesium, then the number of moles of magnesium I'm starting with is mass over molecular mass. So this is the number of moles of magnesium at the beginning. But then not all of it will react. Now, how much of it will react? Well, if I look at the equation, you should realize he had 0.025 mole of acid, and the number of moles of acid should be twice the number of moles of magnesium. So if I have 0.025 mole of nitric acid, this will react with 0.0125 mole of magnesium, because the number of moles of magnesium should be half the number of moles of nitric acid. So this is the number of moles of magnesium that will react, and that means the number of moles of magnesium remaining is the rest of this number of moles that we started with. Now, if I have this number of moles remaining, what is the mass? You should realize that the mass is number of moles times mR. So you multiply this number of moles by the mR, and that means I will have 0.45 grams left. Of course, there are other ways of getting to that answer. So this is one of the methods that you can use. Describe how the student can obtain dry crystals of hydrated magnesium nitrate from the mixture. So he's starting with dilute nitric acid and the excess magnesium powder. Now, he already put that into a beaker, nitric acid and magnesium powder in a beaker. Now, what should he do next in order to get dry crystals of hydrated magnesium nitrate? Well, I have excess magnesium in the beaker, so the first thing I should tell him to do is filter to get rid of the excess magnesium. Now, the filtrate in the flask will be my magnesium nitrate. I can take it and do crystallization and should get crystals from that solution. So what do I explain? That he already said he added the excess magnesium powder to the nitric acid. So continuing, we say, filter the mixture through filter paper and funnel. So in that case, you get rid of the excess magnesium. Then we take the filtrate, heat the filtrate to point of crystallization, cool to form crystals, filter the crystals, and dry between filter papers. Remember, he wants it to be dry. Are we following? Okay. The student repeats the experiment, records the volume of hydrogen gas collected. So now he's doing something else. He's repeating the experiment and recording the volume of hydrogen. And this is the graph. He already gives you the graph. Now he's saying use the graph to calculate the rate at time 40. Remember, at time 40, can you see where time 40 is? You go up to the graph. In order to get the rate, we need to draw a tangent to the graph at that point. Do we understand that? The rate is the volume per second. But in order to get the volume per second, we draw a tangent and we do the change in y-axis over the change in x-axis. So the rate is the change in the y-axis, so the 325 minus 105 in my graph, over the change in the x-axis, which is 63. This gives me a rate of 3.49 centimeter cubed per second. Do you know how to draw tangents to a graph? You should be able to from math, I think. Okay, this question is about hydrated compounds. Crystals of hydrated barium chloride contain water of crystallization. A student uses this apparatus to remove and collect the water from some of the crystals. So he's trying to heat the hydrated to get the water. This is the student's method. Record mass of tube A when empty. Place a sample of hydrated barium chloride in tube A and record the new mass. So that way you can get the original mass of the hydrated crystals. Then heat tube A, allow tube A to cool, record the mass, repeat steps 3 and 4 until the mass recorded is constant. Remember, when we're trying to heat the crystals to get rid of the water, how do I know that I have removed all the water? I have to heat, cool, weigh, and then heat again, cool, weigh, and so on until the mass remains constant. If all the water goes out, then there will be no further change in mass. So we are repeating until constant mass. So these are the student's results. So he has a mass of the tube alone, mass of tube plus hydrated salt, and mass of tube plus the salt without water. Give a reason why the student repeats steps 3 and 4 until the mass is constant. We said we repeat it to make sure that what? To make sure that all water of crystallization has been removed. Calculate the mass of barium chloride that forms in the tube. So this is the results that he has. Calculate the mass of barium chloride alone that forms in tube A. How do I get the mass of the anhydrous, the one without the water? That would be that final reading minus the mass of tube alone, because he has mass of tube A plus BaCl2 and mass of tube A alone. So to get BaCl2, it's the subtraction of the two. Calculate the mass of water lost. How do I get water lost? I have tube A plus hydrated and tube A plus anhydrous. So the difference between them, that will be the amount of water that we lost, the amount of water from BaCl2x water to BaCl2. So that is 0.9 grams. Determine the value of X. So we have a value for barium chloride. I have a mass for barium chloride and a mass for water. How do we calculate X? We do it as if we're trying to get empirical formula. So we divide by the MR of each one. He already gives it to me. That gives me numbers. Then we divide by the smallest. So which one is the smallest? So this is a ratio of 1 to 2, and that means my X is 2, and that means my compound was BaCl2, 2H2. Describe a physical test to show that the water in tube B is pure. What was the test for pure water? Test for pure water? Remember, this is the physical test, and he's telling you, physical test for pure water, heat to boiling, it should boil at 100 degrees Celsius. This is the physical test. So don't say add anhydrous copper sulfate or anhydrous cobalt chloride, which are chemical tests. Physical test to show that water is pure, heat to boiling, it should boil at 100 degrees Celsius. A sample containing 0.02 mole of hydrated copper sulfate is heated using that same apparatus that we used. The products of the reaction of anhydrous copper sulfate are anhydrous copper sulfate and water. This is the equation. What is the meaning of that symbol? Can you remember what's the meaning of that symbol? It just means that my reaction is reversible. Please pay attention to spelling. Many students write the spelling of reversible in different ways. Okay. Describe how the reaction can be used to show that a liquid contains water. What is he doing here? He's saying I have the hydrated, which is copper sulfate 5 water, that's the one that has water. If I heat it, I get the anhydrous plus water. Now, how can I use this as a test for water? And we add the liquid to anhydrous copper sulfate, it turns from white to blue. So it is the reverse of that reaction that he has. You add water to the anhydrous, it becomes hydrated. So it turns from white to blue. Last question, a sample containing 0.02 mole of hydrated copper sulfate is heated using the same apparatus. Calculate the maximum number of water molecules in tube B after the sample of hydrated copper sulfate has completely reacted. So he wants the number of what? The number of molecules of water. He started with 0.02 mole of the hydrated copper sulfate. And from that equation, you can see that 1 mole of copper sulfate 5 water will give how much of water? It gives 5 H2O. So if I'm starting with 0.02 mole of hydrated copper sulfate, then the number of moles of water is 5 times that. So the number of moles of water is 0.1. He wants what? He wants number of molecules. How do we get number of molecules? It is the number of moles times the Avogadro's constant. 6 times 10 to the 23 is called the Avogadro's number or Avogadro's constant. We use it to get the number of molecules or the number of particles. So, number of moles times Avogadro's number will give you the total number of molecules. And that's the end of this paper. I hope it was useful to you. Please use it for revision for your next exam. And if you can share it with others so that everyone can benefit. And thank you for listening.